You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Hybrid search is the practice of combining lexical search, which is grounded in keywords, with dense search, which relies on embeddings, to create retrieval systems that are both precise and semantically aware. The term hybrid emphasizes that no single retrieval strategy fully solves the problem of matching queries to documents. Lexical methods excel at exact matches but falter on meaning, while dense methods capture semantic similarity but sometimes miss critical details. Hybrid search unites these approaches, creating a system that retrieves by both surface form and deeper meaning. In practice, this often means that lexical and dense results are scored separately and then combined into a single ranking. By merging two fundamentally different signals, hybrid search produces results that are more robust, balancing the brittleness of keyword matching with the fuzziness of embeddings. This combination is one of the most important advances in modern enterprise and web search. Lexical search, the oldest and most established retrieval method, functions by matching keywords in a query with keywords in documents. Algorithms like BM25 or Elasticsearch's inverted indexes are efficient, scalable, and well understood. Lexical systems are precise. If a user searches for Section 404 of the Sarbanes-Oxley Act, lexical retrieval can locate the exact passage quickly. However, lexical search does not inherently understand meaning. If a document uses corporate governance regulation instead of Sarbanes-Oxley, a purely lexical system may miss it. Despite this limitation, lexical search remains valuable because many queries demand precision, particularly those involving rare words, identifiers, or structured language. Its reliability makes it an essential ingredient in any hybrid search pipeline. Dense search takes a different route by embedding queries and documents into a high-dimensional vector space. Instead of looking for exact word matches, it calculates similarity between vectors, which represent meaning. This allows dense retrieval to handle synonyms, paraphrases, and contextual variations gracefully. For example, a query for heart attack treatment can retrieve documents about myocardial infarction therapy, since embeddings place them close together. Dense search excels at capturing nuance and generalizing across language variation. However, it sometimes struggles with precision, especially when rare terms or technical jargon appear. It may also surface results that are topically related but not specifically relevant. These limitations reveal why dense search, while powerful, cannot stand alone in high-stakes retrieval contexts. The limitations of pure lexical search are well known. It cannot bridge synonyms or paraphrases effectively, leading to missed results. Polysemy also poses challenges. A query for Java may return coffee-related documents when the user wanted programming results, simply because the keyword appears. Lexical search treats language as surface-level strings, ignoring the semantic relationships that humans rely on. In dynamic or multilingual environments, these limitations become even more pronounced, as lexical search has no mechanism for mapping across languages or contexts. Despite its speed and precision, its rigidity makes it insufficient in domains where meaning, not just form, matters most. Dense search, for all its strengths, also has weaknesses. Because embeddings generalize, they sometimes overlook rare terms that matter. A legal document may hinge on the exact phrasing of force majeure, and a dense retriever could miss it if embeddings cluster it loosely with other contractual phrases. Dense systems may also fail to distinguish between subtle technical variations, such as TCP versus UDP, if embeddings treat them as broadly similar. For factual or compliance-critical queries, this imprecision can be unacceptable. Dense search also requires more computational resources than lexical search, as vector similarity calculations are heavier than keyword lookups. These weaknesses demonstrate why hybrid approaches are necessary. Neither method suffices on its own. The complementarity of hybrid search lies in how each method fills the other's gaps. Lexical ensures precision for rare or exact terms, while dense captures meaning and paraphrase. Together, they cover a broader spectrum of relevance than either can alone. For example, in a medical knowledge base, a query for blood thinner after surgery might match a document mentioning anticoagulant post-operative care via dense retrieval and one explicitly mentioning blood thinners via lexical retrieval. Hybrid search ensures both results are surfaced. This complementarity makes hybrid search robust across domains, whether in academic research, enterprise support, or e-commerce. By combining different signals, it approximates the flexibility of human interpretation. Combining lexical and dense retrieval requires score fusion techniques. Since lexical methods produce scores based on term frequency and inverse document frequency, while dense methods produce similarity scores between vectors, the two scales are not directly comparable. Fusion techniques rescale or normalize them, allowing results to be ranked together. Common approaches include linear combination, where normalized scores are added with adjustable weights, or reciprocal rank fusion, which emphasizes order rather than raw scores. These methods ensure that both lexical and semantic signals contribute meaningfully without one overwhelming the other. The choice of fusion strategy often depends on the domain and task, reflecting the balance needed between exactness and generalization. Metadata filtering adds a crucial dimension to hybrid retrieval. Structured metadata such as author, publication date, file type, or category allows retrieval to be constrained to relevant subsets of documents. For example, a compliance officer searching for risk management may want only results authored in the last year. Hybrid retrieval enriched with metadata filters ensures both semantic and lexical accuracy while narrowing results to specific contexts. This prevents irrelevant noise and enforces precision. Metadata acts like an extra layer of context, aligning search results not only with meaning, but with the structured attributes organizations rely on. The importance of metadata cannot be overstated in enterprise environments. Enterprises often operate on structured repositories, where metadata is as valuable as the text itself. Searching across HR records, contracts, or support tickets requires filters for employee IDs, contract numbers, or ticket status. Without metadata-aware retrieval, hybrid search risks overwhelming users with results that are semantically relevant but organizationally useless. Incorporating metadata ensures that retrieval aligns with business logic and compliance needs, making results actionable. It elevates search from a purely semantic exercise to a tool that integrates seamlessly into operational workflows. Hybrid search shines in scenarios that involve both structured and unstructured data. Legal discovery is a classic example. Cases include structured metadata like case numbers and dates alongside unstructured briefs and arguments. Hybrid search with metadata filters allows lawyers to locate relevant case law quickly while narrowing results by jurisdiction or time frame. In healthcare, patient records contain structured data like lab values and unstructured notes from doctors. Hybrid search enables clinicians to retrieve relevant notes while filtering by patient attributes. These scenarios illustrate why hybrid retrieval is increasingly the default choice for complex, real-world systems. Performance considerations temper the enthusiasm for hybrid methods. Running both lexical and dense retrieval increases computational load compared to using either alone. Query latency may rise as results from two systems must be computed, normalized, and fused. Index sizes grow larger because embeddings and inverted indexes must coexist. These costs are often justified by improved recall and relevance, but must be weighed carefully in production environments. Engineers must optimize pipelines, balancing accuracy against efficiency, especially in high-volume systems where every millisecond of latency matters. Evaluating hybrid search requires metrics that reflect the contributions of both retrieval modes. Recall measures how many relevant documents are retrieved, while precision measures how many retrieved documents are relevant. Hybrid systems often improve recall by capturing results missed by one method, but must also be judged on precision, since retrieving too broadly can overwhelm users. Normalized discounted cumulative gain, NDCG, is also used to measure ranking quality, showing how well relevant results are surfaced early in the list. These metrics provide a holistic picture of hybrid performance, ensuring systems are evaluated on the balance they promise rather than on isolated scores. Modern vector databases increasingly support hybrid retrieval natively. Systems like Pinecone, Weaviate, and Milvus allow simultaneous lexical and dense searches, with built-in support for score fusion and metadata filtering. This integration reduces engineering complexity, enabling developers to adopt hybrid approaches without building custom pipelines. Native support also optimizes performance, since databases can coordinate lexical and dense indexes internally rather than treating them as separate systems. Hybrid support in vector databases reflects industry recognition that hybrid retrieval is not a niche feature, but a central requirement for enterprise and consumer search systems alike. Industrial adoption of hybrid search has accelerated, particularly in enterprise knowledge bases. Companies managing thousands of documents across departments rely on hybrid retrieval to balance precision with flexibility. HR portals, IT support desks, and compliance repositories all benefit from systems that can handle both exact identifiers and semantic paraphrases. Hybrid search has become a baseline expectation in these contexts, not a cutting-edge innovation. Its ability to satisfy both business-critical and user-friendly needs explains its rapid spread, making it a default choice across industries. Hybrid retrieval also sets the stage for re-rankers, which refine candidate results after initial retrieval. While hybrid search improves recall and robustness, it still produces candidate sets that may include noise or require prioritization. Re-rankers apply more sophisticated models to reorder these candidates, producing final rankings that maximize relevance. Hybrid search provides breadth, while re-rankers deliver precision. Together, they form a two-stage pipeline that reflects best practice in modern retrieval systems, ensuring both coverage and quality in the answers delivered to users. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. One of the first challenges in hybrid search is score normalization. Lexical retrieval systems like BM25 produce scores based on term frequency and inverse document frequency, often on a logarithmic scale. Dense retrieval systems, in contrast, output similarity scores, such as cosine similarity, which lie on a bounded scale between -1 and 1. Directly combining these values produces misleading results because the scales are incomparable. Score normalization is therefore necessary to bring them into alignment. Techniques such as min-max scaling, z-score normalization, or calibration against held-out data are used to rescale scores into comparable ranges. Without normalization, one method might dominate the ranking regardless of its actual relevance contribution. The difficulty is compounded by the variability of queries. Some rely heavily on precise terms, while others depend on semantics. Score normalization is thus not just a technical detail, but a core design choice, shaping how the strengths of lexical and dense search are balanced. Weighted fusion methods take normalization further by explicitly assigning adjustable weights to lexical and dense signals. Instead of treating them equally, engineers can emphasize one method over the other depending on the domain or task. For example, in legal search, lexical precision might be weighted higher, since exact statutory phrases matter more than paraphrases. In customer support systems, dense signals may be weighted more heavily to capture variations in how users describe problems. Weighted fusion enables this customization, making hybrid retrieval adaptable across industries. These weights can be tuned manually based on domain expertise or optimized automatically using machine learning on relevance judgments. The flexibility of weighted fusion ensures that hybrid search is not a rigid compromise, but a configurable framework that can be tuned for balance between exactness and generalization. Query expansion in hybrid search illustrates the interplay between lexical and dense methods. Dense embeddings can suggest synonyms or related terms that lexical systems alone would miss. For instance, a query for car insurance might be expanded to include automobile coverage or motor insurance based on embedding similarity. These expanded terms are then passed into the lexical retriever, increasing its ability to surface relevant documents. This synergy highlights how hybrid systems do more than simply combine outputs. They allow methods to enhance each other. Dense retrieval improves lexical coverage through expansion, while lexical precision anchors dense generalization to concrete terms. Together, they yield results that are broader and more reliable. Query expansion demonstrates the practical creativity of hybrid search, turning semantic knowledge into lexical advantage. Hybrid search is particularly powerful in question-answering systems. Pure lexical search may fail when the answer is expressed in paraphrased language, while pure dense search may return passages that are topically related but miss the exact detail. Hybrid systems cover both bases, ensuring that answers are found regardless of wording. For example, a question like, "Who wrote the novel Pride and Prejudice?" benefits from lexical search catching the exact phrase, Pride and Prejudice, while dense search ensures results mentioning boats by Jane Austen are included even without the exact title. Hybrid retrieval thus improves both recall and precision, ensuring that question-answering systems provide responses that are factually accurate and contextually relevant. This dual coverage makes hybrid retrieval indispensable in knowledge-intensive systems, ranging from academic research tools to enterprise FAQs. The impact of hybrid retrieval extends into long-context retrieval augmented generation in RAG pipelines. A model depends on retrieved chunks of text to ground its answers. If the retriever misses relevant documents, the generator produces weak or hallucinated answers. Hybrid retrieval improves coverage, feeding the model with richer and more relevant candidate chunks. Lexical retrieval ensures that precise terminology and identifiers are included, while dense retrieval supplies paraphrased or semantically related passages. This combination reduces the risk of omissions and improves the coherence of generated outputs. In long context settings, where models must weave together multiple sources, hybrid retrieval ensures that the candidate pool is diverse, precise, and semantically rich. It directly improves the downstream quality of generative models, making them more trustworthy and informative. Latency and efficiency are inevitable considerations when running hybrid search. Because it requires executing both lexical and dense retrieval pipelines, query time naturally increases compared to single-method systems. Additional computational overhead comes from normalizing scores, fusing results, and applying metadata filters. However, these costs are offset by improvements in recall and relevance. Engineers often mitigate latency through caching, batching queries, or using approximate nearest neighbor search to accelerate dense retrieval. The trade-off is clear. Hybrid retrieval is more resource-intensive, but it provides higher quality results. Organizations must decide how much latency they can tolerate based on their use case. In real-time chatbots, milliseconds matter, requiring heavy optimization. In research applications, slightly longer retrieval times may be acceptable in exchange for comprehensive coverage. Domain-specific tuning plays a critical role in optimizing hybrid search. Different fields value lexical and dense signals differently, and customization ensures relevance. In medicine, exact terminology such as drug names or conditions must be prioritized lexically, but embeddings help connect related symptoms or treatment descriptions. In law, lexical weighting is critical for statutory language, but dense retrieval captures paraphrased reasoning in case law. In customer service, dense retrieval excels because user queries are often informal, while lexical retrieval ensures product names or error codes are captured. Domain-specific tuning tailors hybrid systems to professional needs, preventing generic configurations from delivering suboptimal results. This adaptability is one of the reasons hybrid retrieval has seen wide adoption across industries. Evaluation benchmarks for hybrid search are evolving to reflect its dual nature. Traditional retrieval metrics like recall, precision, and NDCG remain relevant, but benchmarks must now assess how lexical and dense signals interact. Hybrid benchmarks often test performance on queries that mix synonyms, paraphrases, and exact identifiers. They also measure sensitivity to domain-specific terminology. Some benchmark suites evaluate retrieval under metadata filters, ensuring that structured constraints do not break relevance. These benchmarks provide a way to compare hybrid systems objectively and to measure improvements from score fusion, query expansion, or domain tuning. Without proper evaluation, hybrid retrieval risks being treated as a black box rather than a measurable, optimizable system. Integration with filters is one of the most powerful features of hybrid search in enterprise contexts. By combining semantic and lexical retrieval with metadata filters, systems can answer nuanced queries while ensuring results remain compliant. For example, a search for risk assessment reports can be constrained to documents authored in 2023 by specific departments. Lexical retrieval finds exact keyword matches. Dense retrieval expands coverage semantically, and metadata filters narrow scope to what is organizationally relevant. This three-layered retrieval guarantees both precision and compliance, making it indispensable in industries such as finance, healthcare, and legal services, where results must satisfy strict criteria. Metadata filters ensure hybrid search is not just smart but also accountable. Practical enterprise examples abound. In e-discovery for legal cases, hybrid search allows lawyers to find exact statutory references via lexical search alongside paraphrased reasoning via dense search, while metadata filters constrain results by jurisdiction and date. In HR systems, lexical retrieval ensures precise matches for employee IDs or job titles, while dense search captures semantically similar descriptions of roles or skills. Support portals use hybrid retrieval to locate tickets containing exact error codes while also surfacing paraphrased user complaints. These real-world examples demonstrate how hybrid search is not theoretical but foundational in daily enterprise workflows. By balancing precision, breadth, and structured filtering, hybrid retrieval becomes the engine of organizational knowledge access. Security considerations are tightly linked to metadata in hybrid systems. Metadata filters not only improve precision, but also enforce access controls. For instance, in a corporate environment, employees may be permitted to view only documents relevant to their department or clearance level. Metadata ensures that hybrid retrieval respects these boundaries, preventing semantic matches from surfacing sensitive documents beyond a user's authorization. Without metadata-aware security, hybrid search risks exposing restricted information simply because embeddings align semantically. Treating metadata as both a retrieval aid and a security mechanism ensures hybrid systems meet compliance requirements and maintain organizational trust. Both open-source and commercial tools now provide hybrid retrieval capabilities. Elasticsearch and OpenSearch support hybrid scoring by combining BM25 with vector similarity. FAISS and Milvus offer dense retrieval backends with hooks for lexical integration. Commercial systems such as Pinecone and Weaviate provide hybrid search as a first-class feature, supporting score fusion and metadata filters natively. This widespread availability means that organizations no longer need to build hybrid systems from scratch. They can adopt existing platforms tailored to their scale and use case. The diversity of tools ensures accessibility, whether for small research projects or enterprise-scale deployments. Hybrid retrieval has become a mainstream capability in the search ecosystem. Emerging trends in hybrid retrieval focus on adaptive systems that adjust balance dynamically. Instead of fixed weights for lexical and dense signals, adaptive hybrids analyze the query itself to decide which method to emphasize. A query filled with rare technical terms may lean more heavily on lexical retrieval, while a vague, natural language query may emphasize dense similarity. Machine learning models are being developed to predict the optimal balance for each query, making hybrid systems more responsive and intelligent. These adaptive hybrids represent the next evolution in retrieval, ensuring that search performance is not static, but tailored in real time to user intent. The future outlook suggests that hybrid retrieval will remain the default strategy for enterprise and large-scale knowledge systems. Lexical precision and dense generalization are complementary strengths that no single method can replace. Metadata filters add structured control, making hybrid retrieval not only smart, but also compliant and secure. As RAG pipelines proliferate and long context models expand, hybrid systems will provide the foundation, ensuring that generative AI is grounded in relevant, accurate, and context-appropriate information. Rather than being a transitional phase, hybrid retrieval appears to be the sustainable solution for balancing performance, cost, and trust. In conclusion, hybrid search integrates lexical retrieval, dense embeddings, and metadata filtering into a unified system that balances precision with semantic breadth. It addresses the limitations of each method individually and creates robust pipelines for enterprise and consumer search. From e-discovery to HR systems to support portals, hybrid retrieval has proven itself indispensable. With ongoing innovations in adaptive weighting, score fusion, and metadata integration, it will continue to define the future of search and retrieval. By blending structure, meaning, and compliance, hybrid systems ensure that information retrieval meets the demands of both users and organizations, setting the stage for re-rankers to refine results even further. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.